that's based on the bending moment diagram. So that's what I did. That's why I cut and have the height of each. So let's just start from scratch because we don't want to do 3D models. So we start from scratch. I'm not going to save any changes. And let's look carefully at this model and see the typical floor system and see what we're doing. So it says the story height is 15 foot below, 18 foot above, and for bending moments, we can assume that the columns are, so should be pinned. I didn't mean fixed here, so you guys can spin that mid height. So you guys, that's a mistake. You can just erase that because, as I said, some people will assume it's fixed for the whole height or pinned at mid height. Gives you the same answer. So here you guys need to unchange that on mine. So it's pinned at mid height. So that means that the height below is 15. It says here the story height is 15 below, 18 foot above. So what I'm going to do, I have here a distance that is 15 foot. So I'm going to divide it by 2 because I'm taking half of that. So that's 7.5 foot. And then above, that's 18 divided by 2. So that's 9 foot. And then the spacing here is 20. And have another 20. Like that, right? And by the way, that's grid line. So I'm looking here at grid line B, where here that's grid line B. So this represents grid line B, where I have 2 beams planing into grid line B. And that's going to be grid line 1, that's grid line 2, and that's grid line 3, based on the plan. Call that, this plan we call the architectural grid lines, use the architectural grid lines. So that's grid line B, that's 1, 2, and 3. So I'm looking from this side at grid line B. So I'm saying B is B. So we said that we're going to add some pin. We're going to have a pin at the bottom. And here we allow this to settle. So we put a roller in this direction because we allow it to move. Because if you don't do that, that would not act like a column. It's going to act like a hanger. Imagine if I restrain it from movement downwards, it's going to try to pull up the beam. And we don't want it to behave in this way. We want it to behave like a column, not as a hanger. You guys know what I'm talking about? Okay. So let's look at how this thing would deflect. We have loads here, right, on this beam. So this beam will try, this whole thing will try to move down like this, right? Does that make sense? The whole thing will try to move down. It's going to compress these columns. We'll have some compression. If I use a hinge here where I don't let it move downwards, this would act like a hanger. It's going to have tension force in it. It's going to be like hanging. This beam wants to move down, and this is preventing it from moving. That's why I release the movement in this direction, so let this roller move in this direction, so I don't introduce any forces to this column, any tension, so I don't apply tension. So that's what we do. We unrestrain it in the vertical direction to let it settle, because that's what happens to the columns and move with the whole system. But that's not our main point here. You know, the main so here we're going to have roller. We have roller supports here. Let it move in this direction. Now we need to set, before you do modeling, you need to do, especially if it's your first time to do modeling, you need to draw what you're going to model in a piece of paper and understand what's going on. So I need to define my coordinates. coordinate system. And we like to use, SAP like to use, I can use this point as the origin. You can use any point. You can use this one, you can use that one. But I like to use the one, it's easier to use the one at the bottom left. So everything becomes positive. All the coordinate system is positive. See the point that is bottom left and use it as the origin. So that's going to be my x-axis. That would be the z-axis in SAP. That's x and z. And then based on a right-hand rule, that's x, then you have y is going to be in this direction. So that's y is out of plane right towards the board. You guys know what this is? Yeah, exactly. I just thought it this way. So you see x, z. So there's a big difference between the architectural axes and the SAP grid lines. So the grid lines in SAP are different. So we need to define the grid lines. That's the x, that's the z. We're going to have here the z1 axis, the z1 grid line, z2, z3, and as we said, the distances here is 7.5 and 9. And then we have another grid lines based on SAP. SAP calls that x1, x2, x3. So instead of having 1, 2, and 3, they're going to be x because that's in the x direction. So the first thing we do is that we draw our grid lines. So we have different options. The easiest way to do it is to go grid line only. So I click grid line, and I'm doing x, z only, so I don't care about y. So the y direction asks, the first thing it asks for is number of grid lines I need. So for grid line in the y direction, I only need one. I don't need more because I just need one, which is the x, z plane. I don't need another grid line up the page. In the x direction, I need 3 grid lines. In the z direction, I need 3 grid lines. But z1, z2, these 3, x1, x2, x3, that's what I put 3 grid lines. And then it asks what the grid line spacing, that's something we can change. So in the x direction, I need 20 foot. And make sure you use the right here. You guys see the units here? I made it kip foot. Make sure it's kip foot. Because if you go kip inches and you put 24 inches, that's nothing. It's not going to give you any forces. Y, doesn't matter what value you put. Z, you have 2 different values, so we can change that later. So I'm going to just put 7.5 and then adjust it later and click OK. And that's what I see. That's the x, z, x, y plane. I don't need a 3D one. I want to go on the x, z. I want to go on the x, z, click x, z. And that's the grid lines I see here. That's one. So that's x1, x2. That's so yeah, x1, x2, x3, and z1, z2, these 3. You can double click on these grid lines, and then you can see. So here I can call them x1. I can change the names. x2 and x3. And then the z1 we need to change because it was 7.5, and then the z3 is 9. So that's 9 plus 7.5 gives us a 16.5. But that's the grid lines I need. So that's 20 and 20. And then, well, yeah, 20 and then 40. So that's 40. 20 plus 20, 40. And then I need 7.5, and then the other one is, the other grid line is going to be at 16.5. That's not, you add 9. So you get your grid line. That's what you need. You need a grid line so you can build your model.
How do you get to know whether you're...
You just double click on the grid line here to get these values, or You can right click anywhere, it shows edit grid data. You click on it, you modify, show, and that you get it. So either way, you can double click, or you can just, so you can either double click on any line, any grid line, gives it to you directly, any one of them, or you can right click and edit grid data and choose one grid line. Here we have one system, and then you modify and then alter these numbers if you want to. So then you change the values based on, like if these spans were not equal, I would have changed it easily. You can change that. So now you need to define your elements, and to define your elements, you need, when you do analysis, that's something based on finite element procedure. Based on finite, based on the architect, this whole thing is one column. They don't look at the beam. Based on what we see, we can say that's a column, it's the same column as the first story. Based on structure, as a structural engineers, we need to divide the column into elements. That's why it's called finite elements, elements. So we need to define nodes, and we can call that like our element 1, that's element 2, element 3. We need to be very careful and divide it. At each intersection, we have to specify a new element. So we have 3, 4, 5, 6, 7, 8. We have 8 elements. So that's not one column, that's 2 columns because they intersect with a beam. Any intersection, you have to put a node and start a new element. That's something you have to do. We can't assume that's a one element. So you need to draw. You go to draw, and there's draw frame cable. That's a frame element here. So frame cable tendon. Or you can just, if you want to use the quick links they have, you can just click on this one. It's the same thing as going here and here. So it's the same thing, but I just use the quicker one. And then I define my elements like that. That's one element. That's the second. And then I can right click on it, brings me back to the beam. And then you have your frames. Usually I like to define them from bottom to top and from left to right. And I'll show you why I'm doing that. So you see how I define the columns? They're all from bottom to top. And all the beams are from left to right. And I'll show you why I do that, because I want to be consistent. And there's something called local axes we talk about that are dependent on how you define the direction of each frame element. So I went first one, second one, and so on. And Seb can show you, there is a way it can show you the labels for joints and frames. So let's get the joints off first. So that's the frame, so you guys can see 1, 2, 3, 4, 5, 6, 7, 8. So that's 4, 5, and it depends which one you defined first. So we put 1, 2, 3, 4, 5, 6, 7, 8. Because we started with this before. Okay. So it doesn't matter. And then you can show the labels for joints too. You got joints as well. That's the joints. That's not a problem. Now we need to draw. The first thing we need to do is to draw the model. We drew the model. We need to define the support conditions. So we said these supports, we assume they're pinned. So we can highlight all these joints in SAP and go to assign joint restraints, and then we define them as pinned joints. And click OK, gives us pinned joint. We do the same thing at the top, but the only difference at the top is that we're gonna allow these joints to move in the vertical direction. So you can see here, it says restraint in joint local directions. Local directions meaning X, Y, and Z. Translation 1 means translation in X, so X is 1. Translation in 2 means translation in Y. Translation in 3 means translation in the Z direction. So I want these supports not to move in X and Y. Y actually I don't care about it, but I want it to move in the Z direction. I want it to settle when the whole building, so they don't act like hangers. So I'm gonna uncheck the translation at 3. That's what you do. So you unrestrain it in 3. So it only, you see it looks different. It can move downwards when the building settles. It doesn't take a tension force and try to pull the whole thing up. Now I did all the drawing. I need to do what I did last time, define sections and forces and the regular stuff. So any questions about this part so far? Straightforward. You guys will run into problems when you do it by yourself. It may look easy now, but when you try to do it, try to do it as soon as possible, because run into problems. So the other thing you need to do in SAP is that you need to make sure you're analyzing. There's something called set analysis option. You want to make sure that SAP understands that you're doing a planar analysis, 2D analysis, that you're not considering any movement out of plane. If you don't do this option, it's going to assume that the building is going to collapse out of plane, let it move in the Y direction. So we're doing only 2D, so we want to check XD plane. You click on this. Right here, you see it unchecks some stuff here, but it means that you're only doing plane frame and click OK. Otherwise, if you don't do that, you run it, it's going to tell you it's unstable, because it's going to make it fall in this direction. So see, that's the bad. Computers are stupid, they don't understand. You have to tell it what to do. You want to understand. If I don't give it this information, it's going to collapse.